In this video, we're going to show that the square of an odd integer is of the form 8k plus 1. Now, by their division algorithm, we know that every integer can be written either as 8k or 8k plus 1 or 8k plus 2, 8k plus 3, all the way down to 8k plus 7. And of course, we can eliminate the ones that I just crossed off, because 8 times an integer is even, and if 8 times an integer is even, it's even, and then when you add 2 more, it's even. But this is a little bit too long. We're going to use division by 4. We know by the division algorithm, every odd number or every integer, either it's a multiple of 4, or it's a multiple of 4 plus 1, or when you divide by 4 you get a remainder of 2, and possibly when you divide by 4 get a remainder of 3. Every number can be written this way. These numbers have 4 times 0, 4 times 1, 4 times 2, 4 times 3, 4 times 4. These numbers are one more than 4k. There's 1 and 5 and 9 and 13 and 17. These numbers are 2 more than the 4 table. So instead of 0, 4, 8, 12, 16, I'm 2 more. 2, 6, 10, 14, 18. These are 3 more than multiples of 4. 3, 7, 11, 15, 19. And of course, and so on. Well, look, we have every number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, etc. I should say we have every non-negative integer starting at 0. We have every integer starting at 0. Of course, I could have let k be negative, and 4k would then be, it would have 0 and 4 and 8 and 12 and 16, etc. But it would also have negative 4 and negative 8 and negative 12 forever. And now, if I add 1 to each of those numbers, I'll have 1 and 5 and 9 and 13 and 17 and negative 3 and negative 7 and negative 11. And if I add 1 more, I'd have 4k plus 2. And in fact, I would then get all integers. Every integer can be written in one of these 4 forms. And for the record, okay, so now, why can I use division by 4? The division algorithm using 4. And the reason is when you square 4k, you get 16k squared, which is a multiple of 8. 8 times 2 to be exact. 8 times 2k squared. But nonetheless, it's a multiple of 8. And if you take 4 squared plus 1, you get this squared, which is gonna be a multiple of 8, plus 2 times that, which will be a multiple of 8, times 1, which is a multiple of 8. It'll be 16k. And then you add 1. This is a multiple of 8, this is a multiple of 8. Their sum is a multiple of 8, plus 1 more. If you are 4k plus 2, you're going to square this, and you're going to get a multiple of 8. And when you multiply 4k by 2 times another 2, you're going to get a multiple of 8. And when you square the 2, you get 4. multiple of 8 plus multiple of 8. That whole sum is a multiple of 8 plus 4. And if you take 4k plus 3 and you square it, you're going to get this squared, which is a multiple of 8, plus 4k times 2, which is a multiple of 8. When you multiply that by 3, it's still a multiple of 8, plus 9, which I'll write as 8 plus 1. Multiple of 8, multiple of 8, multiple of 8. When you add them, you get a multiple of 8 plus 1. But we only, so maybe we'll call this one 8 times k. It's a multiple of 8 with no remainder. No remainder. Thing is this is an even number. If you add 2 more and 4k is even. So 4k is even, you add 2 more, it's even. We don't want to know what happens when you square an even number. We want to know what happens when you square an odd number, like 4k plus 1 and 4k plus 3. You always get 8k plus 1. Now, why is 4k plus 1, say union numbers of this form, union numbers of 4k plus 3? Why is this equal to all the odd numbers? Say non-negative. Well, if k is 0, so these are one more than the 4 table. So it's 4 plus 1. Okay, 4 times 0 plus 1. 4 times 1 plus 1 is 5. And 9 and 13 and 17 and 21. And you add on 3 more than multiple of the 4. 4 plus 0 plus 3. 4 plus 3. 4 times 3. 4 times 2 is 8. Plus 3 more is 11. 4 times 3 is 12. Plus 3 more is 15. And then 19. Look, you have 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. It turns out that every odd number is either one more than a multiple of 4 or 3 more than a multiple of 4. 1, 3, 5, 7, 9. This is 4 times a multiple of 4 plus 1. This is 4 times a multiple of 4, 0 plus 3. This here is 4 times, this is the multiple of 4 plus 1. This number is a multiple of 4 plus 1. This here is a multiple of 4 plus 3. Every other odd number is a multiple of 4 plus 1, and the other ones are a multiple of 4, 3 times 4, 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. Okay, you get a multiple of 4 plus 3. So you like videos where we think rather than doing things mechanically? You should subscribe to this channel. What we do mostly is just do proofs all day long. Every day I submit a new proof for you guys to look at. If you like that, subscribe to my channel. Please leave a comment. Let me know what you like and dislike about my videos. Tell your friends about my exciting videos. See you guys in the next video. But most importantly, watch and learn.